Hello, my name is Elaine Evans. I am an extension educator and researcher at the University of Minnesota, and I'm going to talk to you today about public engagement in native bee monitoring. I'm going to talk about some of the broader issues, and then I'm going to go into an example with a project that we had here at the University of Minnesota through our extension program. If you're involved at all in pollinators, you realize that there's a lot of public interest in pollinators. People love pollinators. There's an engaged public that covers a broad range of ages and abilities, but they are ready and capable to help at different levels. Looking at what's needed for native bee monitoring, there are a few questions that often bubble up to the top. We're wanting to have more information about what bee species are in decline. For those bees that we know are in decline and are of conservation concern, we need information about where they occur. And there's also an interest in knowing about what's happening with pollination services from bees. Looking at what's possible for public engagement, there's generally a couple different routes that can be gone. One is using species level identification of bees. This is usually able to be done with a subset of bees. There are some programs, the Oregon Bee Atlas is doing an amazing job with really engaged volunteers that are getting to a lot of species level identification. There's also the option to look at morpho groups. So I'm going to go a little bit more into these two options. For species level identification, there's the possibility to have this really broad public engagement through public biodiversity portals like iNaturalist. So these kind of portals where people are just submitting photos of bees that they see gives us information about where bees occur and what bees are there. There tends to be a lot of observations of bumblebees, but I wanted to also just point out that there are a lot of other species that can be identified to that level when there are high quality photos available. And all these data are really focusing on distribution, letting us know where bees are. When we want to look at those questions of population status, what's happening, what species are in decline, we really need to get into a finer level of detail. We need to have more highly trained volunteers that can use methods that use equal sampling effort. For looking at morpho groups, so this is this idea of using these broad groups, something that requires minimal training that can engage more volunteers. There tend to be broader groups like bumblebees, honeybees, green metallic bees. There are a lot of other options that kind of vary a bit regionally. Some of what happens here is that clearly it washes out some of those data that we're interested in for particular species of concern. But there is still the possibility of these data being useful for broader community composition changes. So if questions are looking at habitat restorations over time and they just want to know what's happening across this broad community, these kind of morpho group data collections with the public can have some use. I'm going to go into the example we have with our program, the Minnesota Bee Atlas. I did this project within the University of Minnesota Extension, along with my colleagues Colleen Sadisher, Britt Forsberg, Thea Evans, and Rob Blair. We're not the first ones or the only ones to do anything like this, but I wanted to talk about our program to highlight the tiered approach that we used. So we did have 3 tiers. We had casual observations looking at all bees, and we had structured observations looking at both bumblebees and tunnel nesting bees. For those casual observations, we used iNaturalist, this public biodiversity portal. Here is an example of an observation that was submitted by one of our Bee Atlas volunteers who got really into what they were doing. They have almost 5,000 observations in iNaturalist, not just bees, but lots of bee observations from this particular volunteer. They were able to submit this photo, identify it to genus level, it's a Perdita bee, and then what happens is that other people, anybody who's on iNaturalist, can go in and suggest an identification. When there are 2 or more identifiers that agree on the species and there's no conflicting ideas, that observation becomes research grade. It is clearly best practices to have somebody with bee knowledge go in and review and confirm these data if you're pulling them out from iNaturalist and want to be using them, as there can be things that happen where one person may identify it. That second person that's making it research grade may not necessarily know everything that they're doing. They may be looking at an identification and thinking like, oh yeah, that looks reasonable, without necessarily doing the kind of confirmation that's needed. Our outcome from these iNaturalist observations, lots of observations, most of them were identified 2 species. There were lots of species, 134 out of our 189 species in Minnesota. Many of those species observations had just 1 or 2 observations. An exciting find was Bombus frigidus, which had not been documented to occur in Minnesota since 1939. So we were really excited to see that this really pretty cool bumblebee is still in the state. Our top 10 species in terms of abundance, heavy bias towards large, easy to ID bees, and also bees of public interest. So despite rusty patch bumblebee being one of the more rare bumblebees in Minnesota, it came out in the top 10. But this is exactly what we want to have happening. We want to have more observations, and any observation we can have of the rusty patch bumblebee, so that we can know where they occur, and we can have recovery efforts focused on helping them recover where they occur. Digging into that identifier issue again, here are our top 10 identifiers from bees within the iNaturalist Minnesota Bee Atlas project. 2 of those top 10 identifiers are bee taxonomists. Neither of them were directly associated with the project, but they're going in and spending a lot of time helping this community by identifying bees to species level. We also had 3 in our top 10 that were either Bee Atlas program staff or some of our highly trained volunteers. So even though the public is submitting these observations, we are still relying on expert input for identification. Looking at what we did with bumblebees, when we were putting this together, we looked to previous statewide surveys in Vermont, Maine, and Nebraska. One of the key adaptations we did was using non-lethal methods. So our observers would adopt survey routes, and then they would visit them 3 times over the summer using equal effort. They would capture and capture bees for 10 minutes, recording the flower that they were from. It was really lucky that we had decided to use only non-lethal methods, as the rusty patch bumblebee was listed as an endangered species 2 years after we started the project. So fortunately, we had methods that worked with that. Our volunteers then photographed and entered those data onto our Bee Atlas website. We were able to document occurrence for rare bees, so we were able to expand the known areas for Bombus affinis. So the yellow areas are marking before 2017, where we had recent documentations of Bombus affinis rusty patch bumblebee. And then our volunteers had 3 new areas outside of those known areas for helping us know where these bees are occurring. We also were able to get baseline population data. So we're able to look at actual abundances of bees and do some comparisons between the different biomes. But also the hope is that that we can repeat these methods in the future and be able to make comparisons about what possible changes there are with bumblebee abundance. And we have this at the species level. Though here it's summarized just bumblebees overall. For the tunnel nesting bees, for the methods that we developed here, we looked to the Bees Needs Project in Colorado. And what we did was we had volunteers hang blocks. They then monitored the nests about every 3 weeks, and they looked for those tunnels being closed up. They noted the different kinds of materials that were used, and then they returned that block to us in the fall. They also entered these observations on our website. We then were able to rear the bees out and identify them. The outcomes for this, we were able to expand and clarify distributions for 29 different species. The example here is Megachile campanulae. The black dots are noting observations from either the University of Minnesota Insect Collection or iNaturalist observations. And the blue circles are from our bee blocks. You can see we were able to greatly expand for this species. We have similar maps like this for all 29 species. We were also able to get information about phenology by looking back at those nest completion dates and connecting it with the species. These data can be important for long-term monitoring, being able to know what was happening phenologically at this point in time, especially with concerns about climate change, to be able to look back and see how things are possibly changing. All of the data that we collected, both the bee specimen and the observational data, are all available publicly through the Minnesota Biodiversity Atlas. This is a public database for any kind of biodiversity observations in Minnesota that is hosted by the Bell Museum at the University of Minnesota. Looking back at our tiered approach and how it worked with these different questions, so looking at those distribution and occurrence data, all 3 tiers were able to give us information that was helpful for that. For looking at which species are in decline, that the bumblebee surveys with the higher level of volunteer training were really able to help us with those questions. Going back to these questions I brought up at the beginning, clearly, as you noticed, we didn't do anything looking at pollination services, but I just want to bring it up here again, and that there are lots of possibilities for ways to engage volunteers to answer these kinds of questions as well. Hopefully you're feeling inspired to start something like this in your state or your region, and wanted to talk a little bit about what it took to make this happen. So with all of these approaches, there are time and money that go into these things. For those casual observations, it's super easy to set up an iNaturalist project and gather those data. It does still rely on expert ID and time on the back end to go through and look at those observations and make sure that they're making sense. For the structured surveys with the bumblebees and the tunnel nesting bees, those involve a bit more time, a bit more money. The tunnel nesting bees was on the higher end of both of those, as there's additional costs with postage and materials and time for rearing the bees out. We did have one full-time program manager throughout the 5 years of this project, as well as 2 scientists. Myself, I was overseeing the bumblebee side of things, and Colleen Sadisher was overseeing the tunnel nesting bees. Our funding for this project came from the Environment and Natural Resources Trust Fund. This is lottery money from the state of Minnesota that we're really lucky to have to be able to support these kinds of projects. Looking at the different kinds of questions for public engagement for native bee monitoring, there's a lot of different kinds of questions that the public can be engaged to help answer. There are these different tiers, different levels of entry, depending on what kind of program you're able to run in your area. In the future, I'm hoping that we can make more of these engagements of the public possible by having researchers work with extension and vice versa to mobilize this interested and capable public. Thank you. I'm happy to talk with anybody who is interested about this topic. Feel free to reach out to me, and let's discuss what the future holds.